All right, so we just finished talking about adding and subtracting polynomials. Now we want to talk about multiplying and then going in reverse from multiplying, which is factoring. So the point of today, you should be able to multiply a monomial by a polynomial and simplify it. We're going to talk about how to recognize the greatest common factor for a polynomial and then use that greatest common factor to help us factor. Okay? Multiplying. When we want to multiply a monomial times another polynomial, so I'm going to multiply this guy by this whole guy, right? That's what we're doing. We're taking a monomial times an entire polynomial. In order to do that, first we've got to write it this way, right? We put the polynomial in parentheses to indicate that we want 2x to the third to be multiplied into that entire polynomial. To make that happen, we do what just kind of seems natural when we see something sitting on the outside of some parentheses, and that's distribute. Okay, so we're going to multiply the coefficients together. 2 times 3 is 6. X to the third times x squared is x to the fifth. Just add the exponents. 2 times negative 5 is negative 10. X to the third times x is x to the fourth. And you add the exponents. And then 2 times 7 is 14. And we don't have anything to multiply the x to the third to here, so it just stays x to the third. We would look to see if we can combine like terms or rewrite in standard form, but it's already in standard form and there are no like terms, so we're pretty much done with this guy. And that's it. Okay? Number 2. Doesn't get a whole lot more complicated when we add variables. Still going to distribute because I'm multiplying this monomial times this entire polynomial, this trinomial. So when we do, we take the negative 3 times 2 and get negative 6. X to the first times x squared is x to the third. Y squared times y is y to the third. Negative 3 times 5 is negative 15. X times x is x squared, x to the second. Y squared times y squared is y to the fourth. Negative 3 times negative 7 is positive 21. And then y squared times y is y to the third. Or sorry, x, there's nothing to multiply the x by. Y squared times y is y to the third. Okay? Again, we would look for like terms, but there aren't any. And we are in standard form, so we're done. Okay? All right. Try this guy. Try number 3. See what you come up with. So stop the video, try to multiply it out, and then start it back up and check your answers. Okay? You should have gotten negative 5, x to the 6th, y to the 6th, plus 20, x to the 5th, y to the 5th, plus 5, x to the 3rd, y to the 5th. Distribute, distribute, distribute. And so hopefully you can see where those are coming from. If not, come talk to me and we'll figure it out. Okay? Some of these have already worked out. All right. So anyway, I guess a situation like number 4 here, we want to sort of distribute twice. We want to distribute the negative x squared here and the negative 3x here. Then we're going to worry about combining like terms and writing in standard form. Negative x squared times 2x, negative 1 times 2 is negative 2, x squared times x is x to the third. Negative x squared times 8 is negative 8x squared. Negative 3x times 5x is negative 15x squared. Negative 3x times 7 is negative 21x. Now if you look, you've got like terms here that you want to combine. We get negative 23x squared when we do that. And so our new polynomial turns into that. Okay? So not a whole lot more complicated. Just distribute a second time and then combine like terms. Okay, try 5 here. Stop the video, start it back up when you're done, and see if you got it right. Okay, did you get this? Distribute those 2 times, and you won't end up with any like terms, so we just get negative 32 x squared y squared plus 28 x squared y minus 24xy minus x squared minus 3x. Okay? All right. Another one for you to give a shot here. Try this guy. Remember to combine your like terms, and then see if you get it right. And did you get this? So when you distribute the 4, you get 4x squared minus 12. Distribute the positive x, and you get x squared plus x. So you can combine these guys because they're like terms, 5x squared. Then you're going to bring the x in first, and then the minus 12 so that you're in standard form. All right? All right. Now, we're going to talk about factoring, how to go backwards, right? So how to go from, let's find a good example here. Yeah. So how to go from this back to this, right? It's called factoring. You've done it before, a bunch of times before, as a matter of fact. And so before we get to this, review a little bit about what that looks like. Let's say we had something like 8,712. And we want to factor that. And I want to factor it using 3. Right? How would you come up with the other factor that needs to be multiplied by 3 to get 8,712? Well, you would divide 8,712 by 3 and get 2,904. Right? That's kind of the same process that we're going to use here. We're going to come up with a factor to use to factor our polynomial down. And to find out what the other factor is, we're just going to divide. Okay? And I'll show you what all that stuff means. The last thing I want to make sure that you understand is that when we have this 3 and this 2,904 here, we understand that these are factors, and factors are always multiplied together to give you back the original number that you started with. Okay, so whenever we come up with our two factors, we need to show that we're going to multiply them together. All right? All right, so how does that apply to something like this? Well, we have to have a factor first. We have to have the first factor before we can find the second one. The first factor is going to be the greatest common factor between these three, between however many monomials that you have. Okay? Now, common factor, first of all, comes from all of your coefficients factored down. We're going to take anything that's common between them. So, if we factor these guys down, we see that the coefficients have a common factor of 5. So 5 is part of this greatest common factor. We can kind of do this with the x's too, right? X to the third can be rewritten as x times x times x. This guy is just x. This guy is x times x times x times x. Now, how many x's do they have in common? Well, since this guy only has 1, then they're only going to have 1x in common. So 5x becomes the greatest common factor between these three monomials. Okay? We've got to be able to identify the greatest common factor first before we can even try to factor using it. So, with that in mind, take a look at these three and try to come up with the greatest common factor for these three monomials. Well, in order to do that, we could go back and do this, where we factor out the coefficients and then we break out all the variables and find out how many they have in common. And if that makes enough sense to you, then do that. But there is a bit of a shorter way to do this. Okay? When I'm looking for a greatest common factor, I'm finding the coefficients first, and I'm trying to figure out what's the biggest number that will divide into all three of those. And the biggest number that will divide into all three of these coefficients is 7. So that's going to be part of your greatest common factor. The next question is, with the variables, how many do they all have in common, right? They all have at least how many variables? So here's what I mean. This first guy has 2 x's. This guy has 3 x's, and this guy has 5 x's. So they have 2 in common. They all have at least 2 x's. So x squared is going to be part of the greatest common factor. The y's, there's 3 here, 1 here, and 5 here. So the most that they all have together, that they all have in common, is 1y. So y becomes part of the greatest common factor also. So the greatest common factor for these three monomials is 7x squared y. That's what we would use to factor out this polynomial, if it were a polynomial. Okay? Now, how? How do we do that? So we have this trinomial here, which I would rewrite first in standard form because we want everything in standard form. A little bit of math OCD there. Now, greatest common factor. What will divide into all three coefficients? The largest number that will divide into all three. Well, that's a 5. How many x's do they all have in common? And the most that they have is just 1x, because this guy only has 1x. Okay? That's your first factor. Remember what we talked about before. Factors are two things that are multiplied together to get you back to your original expression or number. So what polynomial do I have to multiply 5x by to get back to 5x to the third minus 40x squared plus 25x? Well, just like with 8,712 and 3, we divided that out to see what the other factor had to be. So we're going to do that here. We're going to divide the polynomial by 5x, each term by 5x. Why each term? Because we understand that if I want to take 5x times this polynomial, I'm going to have to distribute it to all the terms. So we're going backwards. Instead of multiplying each term, we have to divide each term. So what happens when we do that? 5 divided by 5 is 1. X to the third divided by x, subtract the exponents, 3 minus 1 is 2, so this becomes x squared. Negative 40 divided by 5 is negative 8. X squared divided by x, subtract the exponents, 2 minus 1 is 1, so this becomes minus 8x. 25 divided by 5 is 5. The x's divide out to 1, and so we're done. I know that if I distribute 5x to this polynomial, I'll get back to this guy up here. Okay? That's it. Find your greatest common factor. That's going to be one of your factors. That's going to be your monomial factor. And then divide that into each term of your polynomial, and that will give you what your polynomial factor is. Okay? Try this guy. Stop the video, start it back up, and see if you're right. Okay? So what we need the greatest common factor. The largest number that will divide into all three of those is 3. And they all have at least 2 x's, so x squared is going to be part of your greatest common factor. Now, if I divide each term by 3x squared, what's going to happen? Well, 9 divided by 3 is 3. 6 minus 2 is 4, so this is going to be x to the fourth. 15 divided by 3 is 5. 4 minus 2 is 2, so there's going to be 2 x's here. 12 divided by 3 is 4, and then the x squareds divide out, and so we're here. Those are your two factors. Okay? All right. Try this guy. Stop the video, see what you get. And did you get this? 4x times 4x squared plus 2x plus 1. Okay? Remember that anything divided by itself is just 1. So when 4x, we get 4x divided by 4x out here. That's going to leave you a plus 1. So you do have to add the 1 out there. Okay? All right? Another one here for you. Give it a shot, stop the video, see if you're right. And hopefully you came up with this. So 7x squared y is the greatest common factor. And then when we divide each of these by 7x squared y, you can kind of see what happens. 21 divided by 7 is 3. X to the fourth divided by x squared is x squared. Y to the third divided by y is y squared, and so on and so forth. Okay? If you're not getting this, you need to make sure you come find me and we'll talk about it. Okay? Another one here for you to try. And this is what you should come up with. 3xy is your greatest common factor, so that's the monomial sitting outside the parentheses. And when you divide by 3xy, you should get 27xy plus 3y squared minus 1. Okay? Right. A couple more here for you. Try 14. And here's 15. Fill that in. Try these two and see what you come up with. Bingo. 5xy is your greatest common factor. So you divide 5xy into all three terms there. You should get 3x to the fourth plus 6xy squared minus 8y. And for this guy, we're going to factor out just an x. That's all it has in common. That's all these two guys have in common. So divide by x, and we get 5x plus pi. And that's it. Pi is a weird number, but it's just a number. 5 won't go into pi, pi won't go into 5, so they don't have any common factors that way. Okay? Now, I'll show you 15 because we're going to get into a couple of problems here where you have to come up with the area of a shaded region. And so here's one where we have this box that's been shaded in, and then we're cutting out a circle. So we don't want all of that area. The area that we want, the area of the shaded region, is going to be the area of the box minus the area of that circle that's been cut out. Well, first of all, the area of the box is going to be length times width. Width is 4x. What's the length? Well, because the radius of this circle is 2x, right, we can kind of find the diameter by adding 2x to itself, and that'll give us the length here, which is going to be 4x. So this is actually a square. So I'm going to take 4x times 4x and subtract out. How do you find the area of a circle? Well, it's pi r squared, and r here is 2x. So multiply this out. 16x squared minus 2x squared, 2x squared means that we distribute the square, remember? So we get 2 squared, which is 4. Pi usually comes next, and then x squared is just x squared. Then you want to factor that. The greatest common factor, 4 will go into both, and x squared is the number of x's that they have in common. If I divide the first term by 4x squared, I'm going to get 4. And the second term, I'm just going to get pi. So we get 4x squared times 4 minus pi. Okay? All right, try your hand at this one. Stop the video, start it back up, see if you're right. And there you have it, right? The area of the box is going to be 3r squared because it's a square. The area of that circle is pi r squared, and the radius is just r. So we square out 3r, and you get 9r squared minus pi r squared. Then they have a common factor of r squared. You divide that out, and you're left with 9 minus pi. And that's the area of that shaded region. Okay? Hopefully that makes enough sense. Homework's out in Canvas. Give it a shot. We'll see you next time.